Hi everyone, once again welcome to this class. Um, we are continuing our class on the programming class. Um, Today we will continue our discussion on the Python. We were looking at several things, basically like a lot of basic constructs, a lot of data structures. We looked at several things, and in fact in the last lecture we also did some of the file IOs, how to open a file, how to read a file, how to close a file, how to actually write into a file, things like that. We saw all the details regarding how to use them. We also did a lot of functions, the built-in functions essentially, and then we also kind of understood some of the concepts with underscore, then the name underscore. That's again another built-in um, functions that we can call into. Also in the last class we talked about a lot of these importing Python scripts from some other location. How do we import them? How do we import a whole bunch of scripts, bunch of functions, and then how do we actually use only like few of them, things like that. We saw like several options that are available in the Python language to support that. So today we will shift our gears. Actually we will be covering a couple of chapters. The first chapter is going to be just on the um, the documentation. We will talk about the comments, the dir, the directory, and then the documentation strings. What are the different things that we can do here? And then we will also like look at some of the object-oriented functions that are available in Python. This is mainly the class and the class libraries. This is something that we will go through. Okay, so without a lot of other intro, let me go to the comments string. So comments, we actually saw this much earlier, probably in the first class. Anything after a hash character is a comment. This can be basically on a line or at the beginning of the line, wherever you put a hash and then type in something else, that is treated as a comment. So nothing special about it. I mean, you can write comments everywhere. In fact, I'll urge you to write comments, lot of comments in your script, so that it becomes readable for the next person who will support these scripts. The dir function essentially, like, I mean, it prints out all the attributes of an object. So this object and attributes actually, like, I mean, we will study later when we talk about the class and the class libraries. But just think about, like, I mean, if you have some objects, we can just use dir to report all its attributes. So for example, here we are importing sys. Basically, this is again the import functions that we studied in the last lecture. And then when we say like dir sys, it prints out all the various attributes for this sys. For example, underscore display hook, underscore doc, underscore accept hook, underscore name, stdr, all those different functions that are there, that are all like displayed in this one. And then if you specify dir as a square bracket instead of this, and then basically there is a list. So here it displays the attributes for the list, which is add, class, contains, append, count, extend, index, etc. So all the list attributes are displayed when you say like they are list. The square brackets denotes that it is a list. Now comes the doc strings. The doc strings are nothing but documentation strings, which are essentially used as documentation when we write our functions essentially. So strings at the top of the module files, or the top of functions and top of classes can all become doc strings, which are automatically inserted into the underscore doc underscore attribute of the object. So and then we can use regular single or double quotes to delimit the string, or we can also use triple quotes for multi-line string. So these are all, like, I mean, the standard ones that we saw. Need to get to this. Okay, so here as an example, we have a function here which is basically sum xy. This we know, like, I mean, how to define the function with a column. Usually we only put this statement where we just return x plus y, but in this case we will just add this this string here with the quotes. This function just adds two numbers and this becomes the doc string for this particular function. So when we say like print sum dot underscore doc underscore, it prints just the doc string, which is essentially like its attribute. So this is the way to that we can specify the doc string. Now there are also like doc strings available for built-in objects. For example, we can print these doc strings for built-in Python objects by just using the relevant underscore doc underscore. For example, if we import sys, we can do print sys underscore sys dot underscore doc underscore. So this is something that is useful. So I think you can find out what this prints out. Now there is also a tool called PyDoc. The PyDoc is a tool that can extract the doc strings and display them nicely, either via the help command or via GUI or HTML interface. So you can do like help list and then basically it will print out all those different doc strings. And then for any of the documentation, you can just go to the web and then search on www.python.org and you can get a lot of information from this website. Now we will go into the next topic, which is essentially the classes, and this is one of the big topics that we will be talking about today. Mainly, like, I mean, we will first do an introduction to the classes, what are classes, and we will talk about how do we how can we do the what does it mean to actually have a class. Okay, and this is again, like, I mean, as I mentioned, basically this is the object oriented functions. So so we will talk about that, and then we will also we will introduce to the classes, and then we'll talk about stuff and junk. Okay. So the class is essentially, it's a user defined data type. It contains certain member data, which we will define what it is. It also has associated things that it can do. called member functions. So anytime a class is defined, it should have a member data and member functions. If a class is a specialization or a subtype of a more general class, it is said to inherit from that class, and this can give a class access to the parent's class member, both data and functions. So these are all the concepts essentially, like in the object oriented functions. First one is class. So class, as we saw, it's a user defined data type. The class will have some member functions and member data. Now a class can also have what are called subclasses, which are nothing but specialized classes, and these subclasses, once you have, they can inherit this, the member function and member data, plus its own specialized functions and specialized data. So this is the way that you can actually look into what are classes and how the various functions can be defined. So the member function and the member data that the subclass gets from its parent class, that's called the inheritance, or this is basically an inherited class. It's also called an inherited class, and these pretty much these terminologies are all pretty much same as the C++, Java, etc. These are all like general concepts in other languages as well. The classes are built into Python from the very beginning. We actually use this term class many times before. I hope you remember those things, even though we never talked about the object oriented programming itself. And the object oriented programming, basically that is the programming with using all these classes and the members, member functions and member data. The Python is superior to Perl in this sense. Okay, so this is something that you may want to keep in mind. Perl 5 is also object oriented, which has all these things, but Perl was developed as a non-object oriented from the beginning, so it may not have all these things, whereas Python has all the things that are already there. Now, how do we define a class? The class is defined by two things. One is the class name and a suite of code, essentially, or you can also define it as class name with the base classes and then a suite of code. The class definition suite or the code block can contain member function definitions, so you can define all the member functions within this. What this means is basically like whenever you define a data, they are restricted to these member functions and the member data. The base classes though would contain any class that this class inherits from. Okay. Now, what is the member data scope or scope of the member data? The class attributes, that is the member data, defined in the class definition itself are common to the class. So the code block in the class definition actually runs the first time the class definition is encountered, and not when the class objects are just instantiated. So this is another thing that you may want to keep in mind. So when the class objects are instantiated, the code block does not get to run. It only it runs when the first time the class definition is encountered. The class attributes defined for a specific object of a certain class are held only with that particular object, often set using the self keyword. So we will see an example later. But again, so this is basically once you define a specific object, it only has it is held only with that particular object. So when you go into another object or when you start defining the object, this property will also already be gone. So here is an example. Here we define a class called student. The student has various attributes. One is the course, which is we define as Chem3412, and then we define several functions. So first one is the underscore init underscore. So here we give like self, name, test1 equal to 0 and test2 equal to 0, some initial values. So self name is the name that we assign. Self test1 is just called test1, some arbitrary function, or self test2 is also another test2. Now we can say like, okay, what is compute average of self, and then basically that will return, basically it will add like test1 plus test2 divided by 2, and then it gives you that average. And then print data is essentially like, I mean, so you can ask it to print the grade for this particular course in this or grade for a particular name in this particular course is the average of or the complete average of test 1 and test 2. So if you have like multiple students, essentially, like, so you can say like David is a student with the attribute David as his name, 90 and 100. Whereas Bob is a student, like the base class basically as a student class, Bob the name, and his test 1 and test 2 scores. So now we can say like David print data, and then it will print the grade for David in Chem 3412 is 95.0%. So it takes this, compute the average, and reports it. And for same thing for Bob in Chem 3412 is 70.0. So the Dave.print underscore data and Bob dot print dot data, both of them generate these kind of results. So some more comments on the student example. The calling a function with the same name as the name of the class treats an object of that class. I mean, sorry, creates that object of the class. The actual function is called is the underscore init underscore function within that particular class. Underscore init underscore is also known as the class constructor. So whenever we talk about object oriented programming, there are two things that you need to understand. One is what is called a constructor, and then the other one is called the distractor. So the distractor will come in the later on stage, and each time a constructor is called, a different object of that type is created. These different objects will generally have different member data. So one thing, if you had noticed in the previous example, basically the course name was just held constant. It was the Chem 3412 class. But however, the two test grades are specific to each student. So the self keyword has the same role as this in C++ or Java. It points to a specific instance of that class. It's automatically supplied as the first argument to any class member. So it is automatically supplied as a first class member, first argument to any class member function, and it must be used when referring to any member data or function of a particular class, even if the members data, even if it is members data shared among all the instances of the class. Okay. So now we come to what is known as the operator overloading. This is again another important concept, essentially, where you can use the pre-existing functions and then overload them so that to suit your own customized needs. So for example, some certain operators like equal to, double equal to, plus, minus, multiplication can be overloaded to work on a user defined data type as well as a built-in data types like integers. So today, if to test if two objects are the same, if they are integers, we typically use the equal function on that operator. But if you are a user defined data type, and then if you want to compare those two user defined data types, see whether they match, we can overload the equal to operator and implement a function which can compare the two instances of the user defined data type. So this is done by actually defining _eq_ function for that class, and let's see the example. So here we define a class called point, and then the point has in its init_, basically it's the self x is equal to 0, y equal to 0, and then basically it returns self.x and self.y. Now we can also define the equal to testing, and basically in this _equal to_ it's with self and other, and then so we just basically say that return self.x equal to other.x and self.y equal to other.y. So it basically does this testing and then just reports the answer. So here there is a caveat, I mean, that we will talk about. So a equal to point nothing, and then b equal to 0.11, and then now it will print a equal to b. So one thing that we have to do whenever we do the comparison, we need to actually make sure that they are the two objects that are being compared are of the same type. So we could be a little safer and make sure that the comparison is actually between the two objects of the same type, and otherwise return a flag indicating that the comparison isn't implemented by our point class. So if that is the case, then how do we do it? So here we just say basically if not is instance other point, return not implemented, else return self x equal to other x and self y equal to other y. So we can take the same functions and then basically like enclose within this if then else or if else to basically like test for whether the comparison is between the two objects of the same type or not. Now we don't have to stop at overloading the equal to sign. We can also overload other operators, comparison operators. like less than the underscore lt underscore, that is x less than y, or underscore le underscore, which is essentially stands for less than or equal to, and then same thing for eq, which is x equal to y, and then any is the non-equivalent or non-eq, which is essentially not equal to. And then there is a GE and GT. GE stands for the greater than or equal to, and then GT stands for just greater than. So all the logical operators, basically, or the testing operators, we can overload and then use it. So one thing that you may want to note is there is no overloading the call signatures method. In other languages like C++, you can overload the member functions to behave differently depending on how many arguments are passed to the function. But Python does not work like that. The last function defined with a given name is the one that will be used. So the function itself we cannot overload in Python, and then basically it just uses the last defined function, so it doesn't use the ones prior to that. So a small example again here, we have a class A, and then we define a method, and then we'll say like self x, but then we want to change it, we have to just write a new function, which is now here def method is self x and y. So this just overwrites the previous one, and that's how you can get it. So now we come to the inheritance. Essentially, we talked about this a couple of slides ago. So essentially, a class can inherit from another class, allowing a class hierarchy. If a class A inherits from class B, then the class B is the superclass of class A, and state A automatically, class A automatically has access to all the member data and the member functions of class B. So this is another thing that we briefly talked about. So I just wanted to explain this some more. Again, when the class A inherits from class B, the class B is the superclass of class A, and then class A gets all the goodies from the class B. Basically, all the functions are automatically accessible by class A. And if the class A redefines some member function or member data, which is also present in class B, then the definition in A takes precedence over the class B. So it will win pretty much. So now let's look at an inheritance example, how to do the inheritance. So here we define the class as class 1, and then underscore init we define as self data equal to 0, and those are the starting conditions, and then self dot data is data, self dot data. Now we just print out the self dot data. And then we define a class 2, which is an inherited class of class 1. So see how we linked these two. And then when we define a square self, we can basically say like self data equal to self data times self data, which is essentially like now start the multiplication. So one thing to note here is essentially since we define the class 2 as class 1, it gets all these things, essentially even the print or the display command is also there. So we can specify like A as class 2 with 5, and then we can also specify A dot square as well as A dot display. So A dot square is defined here. So this class reference, and then A dot display is actually described inside. So the first one is just a member function specific to class 2, and the second function is an inherited member function from class 1. So we saw like some of the methods. So let's now explore some of the alternative syntax for the method calls. So instead of calling the methods through their objects, we can also call them through their class name. So here is an example. So we define x as this class variable sum x, sum class. Now we can call the method 1 as just x dot method 1 or some class dot method 1. These both syntax are perfectly legal syntax. Now this alternate method may be useful if you need to guarantee that the superclass constructor runs as well as the subclass constructor. So here is another example. We define class 2 as a inherited class from class 1. And then here we can define like underscore init underscore for self data, and then we can also like just mention class 1 dot init class 1 dot underscore init dot underscore, which directly refers to the one that is before, and then we put that thing, and then you can say like insert the class 2 code here. So we can overload an array indexing syntax with underscore get item. So how do we do that? We define a class called testit, and then we say like define underscore get item is self n, and then basically the return the self dot data, and then the nth variable. And now when we want to use this testit, we can just say like a is equal to testit, a dot data equal to jump. So now we get this violation here. Now there are more to the system defined functions. One such is the get attribute and the set attribute. So the get attribute, these functions catch the attribute references for a class. So the get attribute catches all attempts to get the class attribute. So this is example x dot name, etc. And then the set attribute catches all the attempts to set a class attribute. For example, x dot name equal to Bob. So we need to be careful with the set attribute, because all the instances of the self attribute equal to value become self underscore attribute underscore, and then the value will be the attribute value. And this can prevent one from writing code such as self dot attribute equal to value in the definition of the set attribute. So now how do we use the set attribute? So setting the using the underscore SAT or set attribute underscore. So here is one other example. We just say like class some class, and then define underscore set attribute underscore equal to. So this is basically like we capture the initial value, and then when we say like self dot underscore dict underscore attribute equal to value, then it will print the character. And this avoids the syntax like self dot attribute equal to value, which we cannot have in this definition. Now there's another member function underscore str underscore, which is essentially it is meant to prevent a user friendly representation of the class for printing. And then the other one is the underscore REPR underscore, that is meant to provide a string which could be interpreted as a code for reconstructing and class analysis. So now here is one example. So here the class called number, we define the function this is basically underscore init underscore self data basically, and then self data equal to data, and then we say REPR self, and then the return the number with self data. So now when you see this REPR, essentially that's constructed as a that string is interpreted as a code. So here when we say this, that is interpreted as a code. So we say A equal to number 5, and then we say print A, and then finally like the number is basically number 5. Now I mentioned in the very beginning of this lecture basically like there are destructors essentially like along with that go with the constructor. So now let's look at what is a destructor. The underscore del underscore is also known as the destructor, which is called automatically whenever an instance is being deleted. So whenever the instance get blown off, either due to capacity limitation or transistor limitation, so whenever the you want to delete something, basically like the destructor is what is being called. And essentially in Python it automatically does this garbage collection once that instance is being deleted. So the garbage collection is basically it's where the space is reclaimed. So I think you probably have heard about there are different types of memories. The most common one, or basically where all the variables are all kept, is called the heap. Okay, so essentially, whenever you assign a variable or assign a value to a variable, essentially some portion of the heap is taken and then the particular value is written there. So when the heap gets filled up, you cannot write anything more into the disk. So when you remove something, basically, so every time you allocate or you call the constructor which we saw earlier, a portion of the memory is being allocated to this constructor, and then that's when the memory can run out. Everything is kept as a heap and it won't touch any other program. So basically we have other layers that we saw earlier, the very beginning, also in the lectures, the programs are kept at one level, the operating system is in another level, and then there are other supervised functions will be kept in another level. So whenever a constructor is called, basically it gets allocated and allocated and allocated. Now the destructor basically comes automatically and then basically reclaims this memory back into the heap, and that is the job of the destructor. And then Python also normally cleans up the memory used by an instance automatically. So it is not necessary to put this in the destructor. So there may be less necessary than in for example C++. So that's pretty much what I wanted to cover for today. So we went through two important topics. One is we just did some the documentation, basically with the commands, the dir command, and then the block strings. Then we went on to talk about the classes for Python. So basically those are essentially it's a user defined data type, and essentially it's like any other object oriented language. So it has a member function and member data, and then that is for the class, and then you can also define subclasses which, and you can inherit it. It's basically it inherits all the properties of the class, the original class. So it also inherits the member data and the member functions, and then you can add to it some specialized functions and specialized data. And then we went through some examples of the class and how it works. Okay, I think that's pretty much all for today. We will meet and start the CGI programming in the next class.